All right, well, here we go. Astronomy Cast, episode 302 for Monday, April 15th, 2013. Planetary motion in the sky. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. Almost got hit by a hurricane, not a hurricane, wish it was a hurricane. Almost got hit by a tornado on Friday night.
Yeah.
That was interesting, but things are better now.
Good, good. Yeah, that sounds like it was it was pretty scary there for a little while. Now we've got a big
don't
announcement.
drive into a funnel cloud.
Okay, that's good advice. That's news you can use. So we've got sort of an epic thing coming up.
We do. On June 15th, 16th, we are going to take our funding into our own hands and take a page from the Jerry Lewis Telethon playbook and
Skeptic's Guide to the Universe.
Well, them too.
Yeah.
Host a epic 24, maybe even 36-hour hangout-a-thon using the Google Hangout on Air technologies. We are going to bring you scientists, science entertainers, communicators, virtual star parties, hands-on demos, cooking planets, how to learn geology using Oreo cookies. It's going to be science, science, more science, and the goal is to try and raise the funding necessary to keep CosmoQuest going throughout the current funding hold and stoppage and sequestration and everything else that's currently going on in science funding.
Right. We're not going to let a stupid sequestration keep us down.
No, failure is not an option. We shall fund public engagement in science.
Okay. So where can people find out more about what we've got planned?
We have an event page set up on Google+, and we are going to be posting details on cosmoquest.org/blog. We're going to be doing that this evening, June 2nd.
Okay, great. And we'll be mentioning this more in the next few episodes as we record. So, okay, awesome. All right, let's get rolling. So even the ancient astronomers knew there was something different about the planets. Unlike the rest of the stars, the planets move across the sky, backwards and forwards, round and round. It wasn't until Copernicus that we finally had a modern notion of what exactly is going on. Now, Pamela, it's been a really crazy week, so I'm guessing that Mercury's in retrograde?
Yeah, I don't care what Mercury's doing.
All right, that was an astrology joke. Clearly, it didn't hit you as hard as I was hoping it would.
No.
You're clearly numb to them now. So let's go back in, historical times, and I mean the planets. There's what, 5 visible planets?
Mercury, right. Venus, we're standing on Earth.
Earth, yeah.
Mars, Jupiter, and Saturn.
Right. And so the
6.
ancient,
we just stand on one.
Right. We didn't realize that one's also a planet. But the ancient astronomers knew, I mean, as far back in history as you can imagine, people could see these bright objects moving in the sky. And so they knew from night to night that these things were changing their positions. They knew something was going on.
Yeah, they called these objects the little wanderers. The planets means wandering objects. And what they noticed that stood out so much is the planets appeared to move relative to the background stars, which appeared to be fixed in the celestial sphere. So they kept trying to figure out what was going on. For a while, Venus and Mercury were 2 separate objects, one in the morning, one in the evening. They tried to figure out how to configure the solar system. And even without understanding, they did come up with special words for special positions in the sky for these different objects. And they were very careful to notice and try and draw conclusions from things like, well, Mars appearing to move backwards against the stars.
So what were they what was their explanation then for what was moving the planets in the sky?
Well, for the most part, their explanation was some combination, depending on when you look back in history, of gods and glass spheres and things more and less logical in between those 2 extremes.
And so, and as you said, they all, in many cases, they gave them the names of the gods. They had these, the chariots carrying them across the sky, or,
right.
various
turtles.
gods, turtles, all the way down, those turtles. And that was the part that was quite interesting to me, that was that they used to think Venus was these two separate objects. You mentioned that sometimes you'd see it in the morning and sometimes you'd see it at night.
With the outer planets, with Mars, Jupiter, and Saturn, you can watch them over time as they get closer and closer and closer to the sun, come out the other side. They move in predictable ways. And because of this gradual motion relative to the background stars, it was easy to see that this was continually the same object. But with Venus and Mercury, they'd have these elliptical paths through the sky, or snake-like paths through the sky, as they got watched night after night after night. And because their periods are so short, it was hard to recognize that the morning star was becoming the evening star throughout the orbits. It was just two different snakes showing their path through the heavens.
But they're never at the same time. It's like Superman and Clark Kent.
Exactly.
Right. Okay. So then you mentioned that they started to come up with these names. So what are some of the names that they did come up with?
Well, for instance, you have, as you already teased, retrograde motion. And so normally we talk about stars moving in not stars. We talk about planets moving in prograde motion. This is where they appear to be moving in the same direction that the stars generally move, coming up in the east and moving slowly towards the west. And everything was creeping in the same direction. But occasionally, as our orbit catches up and passes one of the outer planets, this difference in motion between the catching up and then the going past will cause those outer planets to appear to suddenly move backwards, to appear to move west to east relative to the background stars. And what's kind of fun is to grab an astrologer and ask them to explain what is physically happening when Mercury is in retrograde. And they don't necessarily understand this physical motion, and that it's just an appearance, not that Mercury suddenly stopped and reversed its actual direction in orbit. But this is just an illusion of things moving past one another.
But you can imagine that from our perspective, right, but way back in the day, it really did feel like the entire universe was orbiting around the Earth, that we were the center of the universe, and the stars kept going around and around, and the planets made this journey. I mean, it really took a leap of logic for Copernicus to shift it so that that the Earth was just another planet and that we were going around the sun like the rest of the planets.
The real issue was one of understanding distance. We're used to things nearby. When you move your perspective, they seem to move relative to even further objects. So, for instance, if you hold your thumb up and switch between looking at it with left eye and right eye, you'll see the background appear to move relative to your thumb. And there was an expectation that if the Earth was going around the sun, then how is it that the stars wouldn't appear to change in position radically, perhaps even, as the Earth went from one side of the sun to the other? The expected change in position was something that people thought could be seen with the eye, and since we don't see that expected change, well, it must be that everything's going around the Earth, so you don't have what we call a parallax effect. Well, it turns out there is parallax for the nearest stars, but it requires telescopes to be able to see it, because the stars are so vastly far away that the Earth's motion from one side of the sun to the other isn't enough to see with the eye, or heck, to even see with most telescopes, that motion, in this case, against the background galaxies that we use to set our maps of the sky against.
So which planets go through this retrograde motion?
The typical retrograde that we think about in astronomy, where we see a planet appear to back up and then move forward, we only get that effect for the outer planets, so Mars, Jupiter, Saturn. But because the inner planets cross going past us on one direction and then cross again going around the sun on the other side, they also have a type of retrograde motion, but it's not caused by the effect of us passing each other, which leads to a forward and backward appearance, loop-to-loop on the sky. It's instead caused by the planet actually being on a different half of its orbit, where we see it going in the other direction.
And so how did the ancient astronomers describe, try to explain what was going on with these retrograde motions?
This is where we ended up with circles on circles on circles. It was Ptolemy who perhaps did the most work in trying to understand this when he attached epicycles to his orbit so that as the planets went around the Earth, the orbit was a circle, and then attached to this orbit was another circle, and it was through the combination of all these circles that he could describe the motion. Now, the crazy thing is, Ptolemy did so much work on this circles all the way down system that he was able to fairly accurately model the actual motions in the sky. His model was false, but it worked pretty well, which is one of those frustrating things for those of us who don't like it when lies work out to appear to be true.
Right.
Copernicus, on the other hand, because he was determined that orbits should be perfect circles, his system also didn't match the orbits of the planets in the sky. And he also had to attach epicycles to his circular orbits that went around the sun. And his circular orbits with epicycles going around the sun wasn't better than Ptolemy's in describing the motions. And that's more than a little frustrating. It took Copernicus and the realization that things can be ellipses to get to actually be able to model the real motions in the sky.
Now, as an an astronomer, and you're making observations night after night, how fast will you see the planets move in the sky?
It depends on which planet you're talking about. Jupiter, it's far out. Saturn, it's even further. So they have very minor motions. Season to season, they don't vary too much. They will edge slowly from one constellation to another. Mercury and Venus, night after night, you can see the changes over the course of the evening. If you take a picture when they first are visible as the sun sets, or if you're good, even before the sun sets. And then you'll be able to measure them to be in a different place in a photograph by the time they set a few hours later when they're at their highest point above the horizon.
I always think it's funny when people, like on Twitter, they'll note, like, what's that really bright star beside the moon? I never noticed it before.
It's not a star.
Right. It's,
Yeah.
but I mean, it's just like there's so much wrong in that comment, right? Because it's not a star. It's obviously a planet. It's probably Venus, maybe Jupiter. But the moon moves in the sky and Venus moves in the sky.
Yeah.
And so, the fact that you're seeing this configuration of the moon and Venus in the sky at this time, is something that happens every couple of months. So,
Right.
so that's the reason you never noticed it before, is because it wasn't there.
And some of the really neat configurations are actually pretty rare. One of my favorite configurations is when you have the crescent moon setting on the horizon so that it looks like the mouth of a smiley face. You can occasionally, as in every few hundred years, get it lined up so that you have Venus and Jupiter appearing like two lopsided eyes up above the smiling face.
Right.
You can get all sorts of neat alignments. Every year it seems like we'll end up with Venus and some planet near a crescent or a full moon, and everyone drags their cameras out. You and I are guilty of that.
Yes.
And these are awesome, and they occur fairly regularly, but it's the really amazing all the planets visible at once in a line in the same direction on the sky. It's those types of alignments that are more rare. And it was all of these alignments that astrologers of old used to take care to take note of, and they actually came up with a whole set of vocabulary words to describe the different positions that planets could acquire in the sky as measured against the sun.
So what kinds of things can we see?
So the one that I think we're most often excited about is when a planet is in opposition. This is when you can draw a straight line from the sun through the Earth out toward that other planet, be it Mars, Jupiter, Saturn. Uranus is one that you can only see with a telescope generally. But when an object is at opposition, it's highest in the sky at midnight, which means you get the least light pollution, and you're also able to see it for the greatest portion of the night, because it will often rise at sunset or a little before or after, depending on what season of the year it is. And so you can just follow it throughout the entire night, taking image after image, watching planetary rotation, watching the moon's orbit. So opposition is a pretty special thing.
Right. That's where you get, with opposition, you both get a minimum amount of atmospheric distortion, and the planet is pretty much at its closest point from our perspective. So it's just going to be its biggest, brightest, easiest to see, the best time to take photos.
And this is also when we're closest to the planet. So several years ago, we all had that horrific email thread of
Right,
Mars is
Mars.
bigger than the moon. And no, it
No.
wasn't. But every once in a while, Mars' orbit, which is an ellipse, and Earth's orbit, which is an ellipse, will allow the Earth, when it's at its farthest point from the sun, to be in opposition with the sun and Mars at the same time that Mars is at its nearest point to the sun. And that brings the two worlds just a little bit closer together and makes it appear just a little bit bigger and brighter in the sky. And that's just kind of neat to try and photograph.
So for everyone, whenever you hear that it's Mars opposition, and we'll use that shorthand in Universe Today and all the a lot of
Virtual
places.
Star Party.
Yeah, exactly. Opposition, opposition. That's good. That's what you want. It's not like
Yes.
it's our enemy. It's our friend. It's lining up for a good picture.
Now, now the
Oh, go ahead.
Now, the one that's our enemy, that's when a planet is in conjunction with the sun. That's when you draw a straight line from the Earth through the planet to the sun, or from the Earth through the sun to the planet on the other side.
And normally conjunctions are good things. I mean, they're interesting because you get two objects close together in the sky. But, a conjunction between a planet and the sun, not
No.
good.
Yeah,
Not
it's a
helpful.
conjunction with the moon and a planet. Those we like.
Yeah, or
Conjunction
two
with the
planets.
sun. That's the enemy for astrophotographers, unless, of course, you end up with a Venus transit. So most of the time when a planet is in conjunction with the sun, it's either just a little bit above the sun or a little bit below the sun on its orbit. And that a little bit above or below means it's not lined up so that we see it directly in front of the sun. But as we experienced about this time last year, occasionally Venus and less rarely Mercury will cross directly in front of the sun, and we can see it moving like a migratory sunspot as it moves across the face of our nearest star.
And I guess that is a conjunction because they're in the same spot. But in this case, it's in front of the object as opposed to behind the object.
So in front, that's an inferior conjunction, and behind the sun is a superior conjunction.
Right. And I guess we can't get that with the Saturn and Mars and stuff. We only get either opposition or conjunction. But
So yeah, it's a superior planet in conjunction, but it can never be an inferior conjunction unless something very bad has happened to our solar system.
okay. Any other positions in the solar system? Like what if we're at right angles to them?
So right angles, we call that being at elongation. So you can have something where it's sun, planet, Earth, and that's pretty much when the planet will appear to be highest in the sky relative to the sun. Anything else, and it'll start to appear closer and closer to the sun in the sky.
And you'll see that as well in various calendars and stuff. It'll say like Mars is at its greatest elongation.
And depending on whether or not it's an eastern elongation or a western elongation, that depends on whether it is furthest from the sun during daylight or during night. And so the goal is to have it so that the sun sets first and then the planet sets second, and we get that one for western elongation. We get that one for eastern elongation. So the sun sets first and then the planet sets.
And is it, as you said, it's like it's high in the sky, so it's good for observing?
Right. So the sun gets down, and then the planet is still high enough above the horizon, which is where all the mucky, nasty parts of the atmosphere are. It's high enough in the horizon that you can try and get some good pictures of it. So Venus and Mercury, they like to resist being observed well in darkness. And so you wait for them to be in their greatest elongation, and that's when you try and capture their picture.
And Mercury's elongation is never more than a few degrees above the
Right.
horizon, while Venus can get pretty high.
And this is why we like to send spacecraft to them. At the end of the day, this used to matter so much for our observational astronomers. We used to wait all just pent up anxiety of what can we see for Mars to be at opposition, for Venus and Mercury to be at their greatest elongation. But now we just send spacecraft, and spacecraft can do so much better than we can ever do from Earth. That now it's an art form, and it's a way of monitoring the weather on Mars, to look for spots on Jupiter. But if you want high resolution imagery, we're no longer trying to do that from the surface of our planet.
Now, are there any other names for the way things can line up? I guess there's transits.
Well, there's also what's called quadrature. So
Quadrature. This is new to me.
quadrature, right. So when something's at greatest elongation, the triangle is Earth to the planet to the sun. When something is at quadrature, it's the planet, the Earth, the sun is the right angle. So elongation, the planet you're looking at is the base of the right angle, um, and then quadrature, the Earth is the base of that right angle.
Right, got it. Okay. And so as I mentioned, we can get transits, which I guess are conjunctions, but
Which are also inferior conjunctions.
right. But well, you could get, I mean, you could theoretically get Mars move in front of Jupiter. It would just, take a few
Yes.
100,000 years for that to line up.
Okay, let me rephrase that. You can get solar transits during inferior conjunctions. You can't get solar transits during any other type of conjunction.
Right, right. There's a page, I think it's on Wikipedia, where they predict these really extreme conjunctions that you might be able to see. And
And you
it's
can play with Stellarium if you're very diligent to find all of these different alignments. And some of them you have to be in just the right place on the planet to see, especially with some of the asteroid ones where we get asteroids appearing to move in front of the planets.
there's one coming in 2020, I think, that's going to be um, Jupiter and Saturn are going to be so close in the sky that you'll be able to see them in the same
Right.
telescope view.
Yeah, that one's going to be kind of awesome. That's going to lead to some really great astrophotography. I'm
Yeah.
hoping that the whole planet has good weather on top of the land masses. It can rain out at sea, but we
I'm
want good weather on
already
the land masses.
gearing up the reporting team for this. It's going to be amazing. Um, cool. Okay. So then, I mean, does the how do the conjunctions or how does the planetary motions then sort of impact our observations of the stars in the background? I mean, we see them passing in front of stars, and was there some value to this?
Well, there can be in some cases. Saturn, in particular, there was a case several years ago of Omicron Ceti, also known as Myra. It's a variable star, and it was seen to pass behind the rings of Saturn. And having this star behind the rings of Saturn allowed us to better map out the density of the material in those rings. So that was a really neat event. Other than that,
Well, I know it was used
it's
for Pluto too. They discovered Pluto's atmosphere
right.
with the same technique. So Pluto passed in front of a really dim star, and they sort of measured the light curve as Pluto was going in front of the star, and then they were able
Yeah.
to detect that Pluto had this really thin, tenuous atmosphere.
And that's been done with Mars as well. So we use it to measure the atmospheres. One of the more interesting things is when asteroids pass in front of background stars. If we can get a group of people on a stripe across the planet Earth that can all see this event, because they're in different places, they'll have a different angle on the asteroid rather. And from all of their different positions, it's possible to actually map out what the shape of the asteroid is based on the timing of when the asteroid blocks out the star. So this is one way that we can measure the shape of potatoes from the surface of the Earth.
Or even if they have moons.
And even if they have moons, we can see that as well. Uh, Other interesting things that have been done, there was research a few years ago that looked at Jupiter when it passed into the same field of view as several background quasars. And work was done to see if we could see how Jupiter's gravity would bend the light from the quasars. The hope was that we'd be able to measure the speed of gravity, and the results weren't good enough to do that. But it was still a really neat experiment of being able to see directly that gravity does bend light in all the different colors.
Right, right. Now, what impact do these planetary motions have on the kind of the math for space scientists, for mission planners trying to send spacecraft to these planets? It's got to be mind-bendingly complicated.
It's not mind-bendingly complicated. Folks like Newton were able to do it by hand, and that's kind of awesome to think about. And they
Yeah,
were
but
able to
Newton was
figure.
very special.
He was very special, but he didn't have a computer.
Right.
And there were actually a whole lot of different people who worked to figure this stuff out by hand. It's how we were able to predict, or not we, but how people in the past were able to predict the position of Uranus based on some of the issues that they were seeing. Um, so we can see directly how the planets affect one another within our solar system. And as mission planners work to calculate out the optimal energy saving, gravity assist orbits for spacecraft, they have to take into account pretty much all the rocks, all the gas bodies that are going to get interacted with. And I actually saw a science fair student do this without a computer. So yes, it's mind-numbingly
Oh, right.
steps.
Right. It's not mind-boggling. It's just mind-numbing.
Yeah, that's the direction I'm going to go. You can
Right.
do it.
Right.
Any of you can do it if you sit there long enough. It's just tedious work.
Or you just use the really cool solar system simulator from NASA.
Stellarium. That
Or
also.
Stellarium.
Yeah.
Yeah. Which will, but there's a great simulator from NASA that lets you like see any spacecraft from any location,
Eyes on the
backwards
solar
and
system.
eyes on the solar system. Yeah.
Yeah.
Backwards and forwards in
Doug
time.
Ellis's work.
Yeah, it's just fantastic. And, you can see it's just running this full-on simulation of every object in the solar system and all of their interactions. But in the future, it's kind of difficult to map this out far enough into the future, right? The chaos starts to build up.
It's one of those problems that you do have to solve it in steps. You figure out at this time interval, where is everything? Okay, in this time interval, where is everything? And every one of these different calculations introduces a little bit of uncertainty, and that uncertainty adds up over time. This is why when we talk about the potential of asteroids hitting the Earth, we deal with probabilities, we deal with likelihoods, but we don't deal with certainties. There are errors in our calculations that we have to take into account. And when I say error, I don't mean that we make mistakes. I mean that when we make measurements, we're not 100% certain of the shapes and the colors of the asteroids, and both the shape and the color affects how they're going to orbit over time.
Right. And then as you try to make these calculations farther and farther into the future, the errors just pile up. The unknowns just pile up
Right.
until you really have no way to know where things are going to be in the future.
And there's crazy things like if you, for instance, have something nice and shiny get revealed when a comet melts off part of its darker charcoal-covered surface, that nice bright place, it's going to interact with sunlight in a different way than darker surfaces, and that will change the orbit. So there's so many different things to take into consideration. It all just adds up through the millennia.
Yeah. Well, thank you very much, Pamela, and we'll talk to you next week.
It's been my pleasure. Thank you. Okay, don't go away. We're just stopping and saving our recordings.
Remember, that's 302.
Okay. Oh, I just saved it as 303. I need to rename it.
Yeah, don't overwrite something else.
Yeah, I've done that one before. I knew I wasn't overwriting. I just...
Yeah. Well, the episodes are live. It would be pretty difficult to overwrite stuff that's already live now.
Don't challenge me. Oh, it's going to slowly attach to my Dropbox.
Yeah, mine's uploaded to the Dropbox too. All right.
Okay, so what questions do we have from our
Let me see.
audience?
So if you have any questions for Pamela, we'll take them. Hit us
Don't literally hit us, please.
with
I
a
won't
tornado.
cry, but I might hit back.
With a tornado.
Yeah, Mother Nature did that.
Oh, and and so the next episode we're probably going to do is equilibrium.
And we'll be doing that some point this evening.
Yeah.
I think we're looking at 5 p.m. Pacific, 7 p.m. Central, maybe?
Yeah. Wesley DeFlita asks about that conjunction thing. I've always wondered, can we have planetary eclipses like Venus exactly over Mercury from our perspective?
Yes, but they're extraordinarily rare.
Yeah, let me see if I can find one. So it would be a transit of Venus.
Or an eclipse. You can refer to it both ways.
Well, hold on. So it's the second. Yeah, so Venus would pass in front of. Right, let me see. a transit of Mercury from Venus, transit of Venus from Saturn, a transit of Mercury from Mars. So there's a bunch of these. So for example, let me see. I found some more here. Wow, there's transits of
Sorry, while I
Phobos.
look over here, I'm trying to figure out where the file I misnamed is located.
A transit of Earth from Mars.
That, I think, has been seen by one of the landers.
So there'll be a simultaneous occurrence of a transit of Venus and a transit of Earth in the year 571471.
That's cool.
Yeah. In January 16th, 18,551, Mercury and Venus will have a transit separated by 14 hours. And a simultaneous transit will occur in the year 18,713 and the year 19,536 and the year 20,029.
We won't be around for those.
No. Well, my third robot body. But that would be crazy. Wouldn't that be cool to see Mercury and Venus
It really would be.
on the surface of the sun at the same time?
Yes.
But yeah, so there's if you do like a search on Google for like transit of Venus from Saturn, things like that, you'll see a bunch. Where did Saturn get its next one? So Saturn gets to see its next transit of Venus in 2028.
See if Cassini won't still be going at that point.
Um,
We need to send out something after Cassini to go explore Titan that can watch that for us.
And then one in August 31st. So anyway, there's a ton of these. I mean, if we can get spacecraft out there, we can increase the number of transits that we see.
The issue is that while they are quite often quite awesome, the amount of science that we get with them is getting less and less.
There will be a transit of Mercury from Venus in 2016, so maybe Venus Express will be able to see it.
That would be cool.
Yeah. So anyway, there's a bunch of these. Let's move on. And you could actually get planets passing in front of other planets, absolutely. But again, just super rare. Young Wu Chun says that I referenced you Harvard style. Thank you for the great information you gave me. So I guess one of our episodes was included in an episode. Sorry, in someone's research paper. So there you go.
That's cool.
That's very cool. Okay, so here we go. So this comes from Jeff Borst. There's a story on the Daily Galaxy about a new evidence from the Planck data supposedly showing hard evidence for multiverses. You seen this?
No.
This crossed my radar, and I was like,
yeah, that doesn't sound completely legit.
Yeah, so where was the original source? I think this was from the Center for Astrophysics.
So there's a difference between evidence, hard evidence, and accepted evidence.
Yeah.
It's sort of like the speed of gravity research that I cited in our show, where we talked about Jupiter being near the quasars. There was a whole press release about how they measured the speed of gravity, and it didn't become a generally accepted result. It became something that people now mock.
Yeah.
And all because something's published doesn't mean all of us are going to believe it.
So this is coming from the Planck data. And I know Thad is watching us right now, and I'm sure he is tearing his beautiful hair out right now about this. But yeah, I don't know. We get this a lot. So I remember what it was. There was sort of like what looked like bruises in the Planck in the cosmic microwave background data. And so one of the ideas is that this is where our universe bonked up against other universes and bruised one another.
Oh dear.
Yeah. And there's also sort of something going around that black holes won't crush you. They may take you to other universes. They're portals to other universes.
No, they just crush you.
They just crush you. So, but apparently this is sort of as part of quantum gravity. So, yeah, there you go. So I will, you know what,
Yeah.
I will definitely have someone look at these ideas and see if there's any, validity to it and whether or not we'll report on it. But, and we're okay to report on speculative stuff, but I require like a little bit of something to dig into, a little bit
Yeah.
of science here that we can go off of, as opposed to, in many cases you really have to track these things back. The more extreme the proposal, the more amazing the evidence. And a lot of the times, someone will say, like, in the original research paper, it'll be like, this disparate data in the cosmic microwave background radiation is similar to the predictions made by this idea of quantum loop gravity. And,
And it's just
and
one of
some,
many different explanations for the
right.
exact same thing. And people will jump to the most interesting explanation instead of the most grounded explanation.
Right, but the journalists, right, my comrades want to just jump straight to, we've found other universes, as
Yes.
opposed to, the math, the discovery of this evidence matches the math as predicted in this other thing. But that's it,
Yeah.
and and yet it, disproves all this other stuff related to that same theory. So
Yeah.
anyway, yeah, that's the
It's
problem with
frustrating.
reporting this stuff. And the problem is that a lot of people, they don't go in with that skeptical view of like, come on, you're telling me there's other universes, you're telling me jumping into black holes is going to take me to other places, then, let's
Yeah.
see the evidence here. And so often I'm super careful and skeptical when we assign those kinds of stories on Universe
Yeah.
Today.
Extraordinary claims require extraordinary evidence.
Yeah. And we've been burned a lot by that. Um, Thad is saying, definitely not hard evidence, definitely a very interesting signal, high confidence in the cold spot that was hinted at the WMAP data. It will be a good site or sites to observe in detail in future cosmic microwave background radiation missions.
And there was multiple explanations for the cold spot that was found in WMAP. So
yeah,
we'll have to see what this is. What we have right now is this unknown that's now been pointed out from two different data sets, that the theorists throw 5 theorists in a room and they'll come out with 7 theories that match the data.
yeah. Robert Scott Herrick noted early on the show, I will never understand how people in tornado country possibly compare living to places that the occasional minor earthquake. I think that's exactly right. I mean, we feel, I've been in a bunch of earthquakes, and I don't find them that scary.
There is the biggest bug I have ever seen flying around behind you.
Is there? Yeah, some big fly.
Sorry.
Might be a horse fly. Yeah. So anyway, so that's, it's just like it's. I mean, when we have earthquakes here, they're, it's kind of like it shakes back and forth, and it's kind of fun. Now obviously it gets unfun as it gets a lot stronger. But for when we have earthquakes, I'm kind of like, oh, cool, it's an earthquake.
I think the issue is when you have an extraordinarily severe earthquake, it will kill tens of thousands of people. They're very rare. Tornadoes, when they're extraordinarily bad, will kill tens to hundreds of people, and they're less rare. So integrate over 1,000 years, and they're the same. So pick which set of probabilities you want to deal with.
Yeah. Fred Newton says, I saw that 1998 QE2 has a moon. Is that rare for an asteroid?
No. I just love the fact that one's QE2.
Yeah,
I laugh every time I hear that.
It's Sandy was saying in the Weekly Space Hangout that it's about 15% of the time they have a moon. And which was great was because she said, well, and if we're lucky, it's going to have a moon. And then I'm like, you called it. You predicted a moon.
Yeah.
And that was where I was giving Nicole a hard time, because I was saying Sandy was out there at the Arecibo Observatory. She went out, plugged her headphones jack right into the Arecibo Observatory, just listened to the sound of
You don't do that. No one does
of
that.
1998 QE2, and she could hear there was a moon there.
No, sorry. No.
Yeah, but Nicole's audio wasn't working, so I could see her screaming, but she couldn't say anything. So, Yeah, it was pretty fun. Okay, cool. All right. Well, I think that's all the questions that we've got this week. So we're going to, like I said, we're going to put another show on the calendar for later on this afternoon, and we'll take another crack at it. And there's going to be another one probably tomorrow. And we're gonna, we're hoping, I think, if Courtney has us fully scheduled, we should be caught up by sometime next week, I think, at this
I
pace.
think the more realistic goal is I'm going to spend the month of July in Europe, and we're going to try and be caught up and ahead before I leave for
Yeah,
Europe.
perfect.
It's going to be a try,
Yeah.
but we'll see what we can do.
When are you leaving for Europe?
July 7th to August 7th.
Okay.
I'll be in Finland for the European Space Week, at Nucleo in Portugal, working with collaborators for 2 weeks, and then I'll be at the Global Hands-on Universe Conference in Velos, Greece for a week.
People want to know if your horse was okay.
Horse was completely fine, and it was so surreal. You can draw a diagonal line with my house on one side of the line, the barn on the other side of the line, and the tornado just went between the two. So it missed the barn by about half a mile, missed my house by 2 blocks, and
Is this where I get to make the obvious joke that it couldn't hit the broadside of a barn?
it hit the broadside of a different barn.
Different barn, yeah. Yeah. Okay, well, I'm going to wrap this up. So everybody, we will be putting another show into the calendar, so you should see it show up in a couple of hours. And if you want to join us later on this afternoon, we'll do another show. Okay. Thanks, Pamela. Thanks, everybody.
Because of this gradual motion relative to the background stars, it was easy to see that this was continually the same object. But with Venus and Mercury, they'd have these elliptical paths through the sky, or snake-like paths through the sky, as they got watched night after night after night. And because their periods are so short, it was hard to recognize that the morning star was becoming the evening star throughout the orbits. It was just 2 different snakes showing their path through the heavens.
But they're never at the same time. It's like Superman and Clark Kent.
Exactly.
Right. Okay. So then you mentioned that they started to come up with these names. So what are some of the names that they did come up with?
Well, for instance, you have, as you already teased, retrograde motion. And so normally we talk about stars moving in prograde, not stars, we talk about planets moving in prograde motion. This is where they appear to be moving in the same direction that the stars generally move, coming up in the east and moving slowly towards the west. And everything was creeping in the same direction. But occasionally, as our orbit catches up and passes one of the outer planets, this difference in motion.
Really crazy week. So I'm guessing that Mercury's in retrograde?
Yeah, I don't care what Mercury's doing.
All right. That was an astrology joke. Clearly, it didn't hit you as hard as I was hoping it would.
No.
You're clearly numb to them now. So let's go back in, historical times. And I mean, the planets, there's, 5 visible planets?
Mercury, right. Venus, we're standing on Earth.
Yeah.
Mars, Jupiter, and Saturn.
Right. And so the
6,
ancient,
we just stand on one.
Right. We didn't realize that one's also a planet. But the ancient astronomers knew, as far back in history as you can imagine, people could see these bright objects moving in the sky. And so they knew from night to night that these things were changing their positions. They knew something was going on.
Yeah, they called these objects the little wanderers. The planets means wandering objects. And what they noticed that stood out so much is the planets appeared to move relative to the background stars, which appeared to be fixed in the celestial sphere. So they kept trying to figure out what was going on. For a while, Venus and Mercury were 2 separate objects, one in the morning, one in the evening. Science entertainers, communicators, virtual star parties, hands-on demos, cooking planets, how to learn geology using Oreo cookies. It's going to be science, science, more science, and science. And the goal is to try and raise the funding necessary to keep CosmoQuest going throughout the current funding, hold and stoppage and sequestration and everything else that's currently going on in science funding.
Right. We're not going to let a stupid sequestration keep us down.
No, failure is not an option. We shall fund public engagement in science.
Okay. So where can people find out more about what we've got planned?
We have an event page set up on Google Plus, and we are going to be posting details on cosmoquest.org/blog. We're going to be doing that this evening, June 2nd.
Okay, great. And we'll be mentioning this more in the next few episodes as we record. So, okay, awesome. All right, let's get rolling. So even the ancient astronomers knew there was something different about the planets. Unlike the rest of the stars, the planets move across the sky, backwards and forwards, round and round. It wasn't until Copernicus that we finally had a modern notion of what exactly is going on. Now, Pamela, it's been
They tried to figure out how to configure the solar system, and even without understanding, they did come up with special words for special positions in the sky for these different objects, and they were very careful to notice and try and draw conclusions from things like, well, Mars appearing to move backwards against the stars.
So what were they what was their explanation then for what was moving the planets in the sky?
Well, for the most part, their explanation was some combination, depending on when you look back in history, of gods and glass spheres and things more and less logical in between those two extremes.
And so, and as you said, they all, in many cases, they gave them the names of the gods. They had these, the chariots carrying them across the sky, or,
Right.
Various
Turtles.
gods, turtles, all the way down, those turtles. And that was the part that was quite interesting to me, that they used to think Venus was these two separate objects. You mentioned that sometimes you'd see it in the morning and sometimes you'd see it at night.
With the outer planets, with Mars, Jupiter, and Saturn, you can watch them over time as they get closer and closer and closer to the sun, come out the other side. They move in predictable ways. And
All right, well, here we go. Astronomy Cast, episode 302 for Monday, April 15th, 2013. Planetary motion in the sky. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. Almost got hit by a hurricane. Not a hurricane. Wish it was a hurricane. Almost got hit by a tornado on Friday night.
Yeah.
That was interesting. But things are better now.
Good. Yeah, that sounds like it was it was pretty scary there for a little while. Now we've got a big announcement.
Don't drive into a funnel cloud.
Okay, that's good advice. That's news you can use. So we've got sort of an epic thing coming up.
We do. On June 15th, 16th, we are going to take our funding into our own hands and take a page from the Jerry Lewis Telethon playbook and
Skeptic's Guide to the Universe.
Well, them too.
Yeah.
Host a epic 24, maybe even 36-hour hangout-a-thon using the Google Hangout on Air technologies. We are going to bring you scientists,